This is the lecture on statistics used in assessment in special education. My name is Dr. George Giuliani from Hofstra University, and this is part 2 of the lecture. We have been discussing the measures of central tendency, looking at the mean, the mathematical average, and the median, which is the midpoint in the distribution. And now we'll be looking at the mode. And the mode is the score that occurs most frequently in a distribution. In a sense, when you look at the different scores in a distribution, which score occurs most often in a distribution? So when you look at our original example of 8, 10, 8, 14, and 40, that original distribution, 8, 10, 8, 14, 40, what is the mode? What is the mode of that distribution? And anytime you set up a mode, or anytime you're looking to find the mode, what you need to do is set up what's known as a frequency distribution. And if you look on your slide, you'll see a frequency distribution in front of you. What we do is we list the scores, and those scores are from the highest score at the top to the lowest score at the bottom, or lowest score at the bottom to the highest score at top. And then you tally it, and those are just the little tick marks. And then you look at the frequency. So a frequency distribution is simply a listing of the scores from the lowest score from the bottom to the highest score at the top, with the number of times each score appears in a sample. So we look at 8, which occurs twice, 10, which occurs once, 14, which occurs once, and 40, which occurs once. And given our situation, or given our distribution of 8, 10, 8, 14, 40, it's apparent that 8 occurs twice, everything else occurs once, and therefore the mode is 8. So our mode in the distribution of 8, 10, 8, 14, and 40 is 8, since 8 occurs twice and all the others occur once. Now, what if you have 2 or more scores appearing the same number of times? What happens when 2 scores appear the same number of times? Suppose you had 8, 10, 8, 10, 14, and 40. So now you have 8 occurring twice and 10 occurring twice. When this happens, you have 2 modes, and it is a bimodal distribution, So our modes would be 8 and 10. So if we had a distribution 8, 10, 8, 10, 14, and 40, 8 would occur twice, 10 would occur twice, the rest would occur once, and therefore we would have 2 modes, 8 and 10, and that is called a bimodal distribution. When you have 3 or more modes, it is called a multimodal distribution. So whether you have 3 modes, 4 modes, whatever it is, it's a multimodal distribution. And when all scores appear the same number of times, if you look at a distribution and the frequency which the scores occur the same all the time, then there is no mode. So if we had a distribution of 8, 8, 10, 10, 14, 14, and 40, 40, all of those scores occur twice, and therefore there would be no mode. So I've given you some practice problems to do for calculation of mode. If you look at our first distribution, 8, 10, 8, 10, 14, and 40, calculate the mode. And then in our second distribution, 8, 9, 10, 12, 14, 40, 14, 40, 12, 10, 9, 8. Calculate the mode there. So take a few minutes to calculate the mode for each of the distribution, put this lecture on pause, and then when you've calculated them, continue on. When you did the problems, or assuming you did the problems, you would find that in the first one there are 2 modes. It is a bimodal distribution. The modes are 8 and 10. And in the second one, since all scores appear twice, there is no mode. So go back and check if you didn't get those answers correct. But in the first problem, the modes are 8 and 10. And in the second problem, since all the scores appear twice, there is no mode. Finally, let me give you a calculate the measures of central tendency problem. Here you have students numbers 1 through 8, Billy, Juan, Carmela, Fred, Yvonne, Amy, Carol, and Sarah. And then accordingly IQ scores associated with each child. And your job is to calculate the measures of central tendency. Calculate the mean, the median, the mode, and take a few minutes to do this. So I'd ask that you put the lecture on pause right now. Calculate the mean, median, and mode for this distribution of students. And then when you are done, turn the lecture back on, and we'll see if you got your answers correct. The answers to the measures of central tendency question, the mean is 100 because you should have added up the scores and gotten 800 divided by 8 total scores. 800 divided by 8 is 100. The median is 102.5. 102.5 is your median, and your mode is 105. Your mode is 105. So again, the mean is 100, the median 102.5, and the mode is 105. If you have any concerns about that or questions about that, don't hesitate to shoot me an email so we can discuss it. The next concept you need to know in terms of statistical terminology is known as the range of scores. And the range is quite simply the difference between the highest score and the lowest score in the distribution. Very easy to calculate. To calculate the range, you simply just take the highest score in the distribution and you subtract the lowest score in the distribution. So in the distribution of 8, 10, 8, 14, and 40, what is the range? Okay, well again, if you look at what the definition of range is, simply find the highest score and find the lowest score and take the high score and subtract the low score. So in our problem, or in our distribution, the range we would see is 32 because the high score is 40 and the low score is 8. So 40 minus 8 is 32. So again, with the range, simply find the high score in the distribution, subtract the low score in the distribution, and you get the range. In our example, 40 is the high, 8 is the low, 40 minus 8 is 32. So at this point in the lecture, you should be able to calculate mean, median, mode, and range. Mean, median, mode, and range at this point. Now, one thing to note with the range tells you nothing about the scores in between the high scores and the low scores. So just like with the mean, extreme scores can greatly affect the range. So for example, suppose you had a distribution and it was 8, 9, 8, 9, 8, and 1,000. The range would be 992 because we would take 1,000 as the high, subtract 8 as the low, 1,000 minus 8 is 992. Yet, as you can see, there's only one score that's even close to 992, and that's the 1,000. So just like with mean scores, the problem with the range is that extreme scores can greatly affect the range. So at this time, we'll stop the lecture here. You can go on to part 3 of our lecture on statistics used in assessment, and we'll pick it up with standard deviation. This now ends the lecture on statistics used in special education, part 2. Go on to part 3.